Table, you're going to create a bubble map explaining in any way, shape, or form, or whatever you can think of that comes to mind about the number 4 and 5/10, or 4.5. All right, so I'm going to give you about 2.5 to 3 minutes to work with your table and create your own bubble map about the number 4 and 5/10. You may begin. Let's start from 4 by 4, 5 times 6, 7.
Couldn't it be a 0 right here? Wait, so let's be
Put 4 and 5/10 first to draw your circle.
Oh, if you bound it, do we use this? Yeah, but like if you bound it, yeah, if you bound it. Look, we put a 0 right here.
Yes.
Is there going to be one rod or everybody?
Everybody can do it. It's teamwork. The people are thinking. I love it. Have about 2 more minutes. Just get as much as you can on that bubble map. As much information as you can about the number 4 and 5/10. Think about everything we went over with decimals. I want to see that you understand these numbers.
I just told everyone.
This table is working together. They're doing a lot of teamwork and collaboration.
It could be
This table is doing the same. You see a lot of information. What do you mean you can get back and go deeper into the government table? I want to know what it means. Four and 5 cup. Okay, so put that down in terms of like, you can use the number 4.5. It's measurable. Good job, Rosie. It's measurable. Great job.
And like another way to
Right? Let's make sure everybody in the group is shooting ideas, okay? What I found to work is that everybody doing something on the chart. That's been working with a lot of other kids too. Okay? Okay, perfect. Have about 1 more minute. Anything that comes to mind. How can you get 4.5? Can you manipulate that number? Anything that it can relate to. I see so many people have created larger numbers, smaller numbers. Some people have broken the number up. That's amazing. You have to share that. 15 seconds.
Wait, we can do that right here.
This train's flowing.
Guys, this is good. I'm just going to add that.
All right, 3, 2, and 1. So, as I'm looking through your chart, I noticed a lot of group work going on. I noticed that either one person had the mark and everybody threw ideas at that person, or everybody had the mark and wrote their thoughts on the paper. So what I need now is one person from each table to just put their thought on the board, because what you have at your table, they might not have at their table. So let's see who can go to the board and give me an example. As you're writing, explain why is it important for me to put this on the board. Share it out with the class. I'll take Kira. Go ahead. What are you going to put up there? Take that marker and go right on the paper. Remember, only the paper, not the smartboard. Only the paper. All right. I need someone from this table. Give me Umar. Kira, what are you putting on the board? Okay, go ahead and write that. Huh? Draw a line. You're making the same map that you made at your table. All right. Umar, what are you putting on the board? Okay, great job. And make sure people can read it from afar. You don't want to get there and write really small because Osmond's not going to be able to see that. Okay, so you want to make sure you write it big so people can see it. All right. Let me get Alexis. What are you putting on the board?
I'm putting 4 and 5/10 in expanded form.
Okay, great job. Expanded form. We're breaking down these decimals. Favor. So you can talk to us while you're going up there.
You can make it a whole number by multiplying by 10.
You can make it a whole number by multiplying by 10. Yes, because that right there is a decimal number which differs from a whole number. Brian, what do you want to put on the board?
Turn it into a fraction.
You can turn it into a fraction. Great. Go ahead. You can turn it into a fraction. Oh, okay. Leslie, what do you have?
You can use that as a way to measurement.
Okay, so it's measurable. Okay, you can write that on the board.
Can I write it's a decimal?
Yes, you can write that on the board. Leslie, you have to wait till Favor gives you the marker back. Jahandris. It can be rounded. Please put that on there because that is very important about that number. Isaiah.
4 and 5/10 equals to 4/5.
Equals to 4/5. Think about that, buddy. 4 and 5/10 is equivalent to a fraction, but I need you to think about that one. Jaka. You can put 4 and 5/10 into work, and we have that up there. I think 4 and 5/10 are equal to 4 and 1/2. They kind of wrote it and put two things in one. Robert. It can be divided. Yes, that's a great one. All right, we're going to stop with the information we have right there. All right? We're going to stop with the it's so much information. You can continue to talk about this number all day. About a split into 4.5 people, 4 and 5/10 people. I don't know how that exists, but we can just continue to talk about this number, right? So what we're going to do today, when our friend Leslie finishes, great job, Leslie, is we're going to just talk about how numbers relate in various ways, right? So this is perfect. Let's take this down. Can I get someone to read our objective for today, our I can statement? I need somebody to be loud and proud, all right? Let me get Abigail, loud and proud.
I can understand fractions as division in order to answer real-world problems with fractions and visual fraction models.
Right, perfect. So these are real, what we're about to go over is real life problems. Real life problems for a 5th grader, okay? Maybe a 24-year-old like myself. Well, I'm almost 25. But these things happen in real life. Like when you get to the last cupcake and 3 people want it, or you get to that last Skittle and 7 people want it. Can you split a Skittle? You can split one Skittle? No. Well, let's show me how to do it, okay? All right, so with your tables for the next 3 minutes, I want you to talk about this word problem right here. Who can read the word problem on the board? Ashley.
If you had 8 pieces of candy and you shared them equally with 3 of your friends, how many pieces would each of you get?
All right, now before we start that, I want to make sure we have a foundational understanding of what operation are we focusing on here? Multiplication.
Fractions?
Fractions. Operations, not numbers. Sanaya. Division. Great job. So in this, we need to know that there are 3 things in a division problem. And what are those 3 things? Khalid? The dividend. Great job. And what is the dividend? It's the number that's being divided into groups. Great job for using your resources because the vocabulary is right there on the board. What else do we have, Jaka?
The quotient.
The quotient. What is the quotient?
It's the answer to your division problem.
It's the answer. So when someone says, can you find the quotient, we know we're looking for the what? The answer. Great job. The answer to the problem. And we're missing one more. Leslie.
The number of groups that divided will be separated.
Great. Great job. So the divisor is the number of groups that the dividend will be separated or partitioned into. All right? So the divisor is very important, and the dividend is very important. So with your tables, I want you to try and solve that problem for the next 3 minutes. It's very easy. Go ahead.
And then I think you might have a round
Make sure you read that word problem carefully.
Each.
So what number are you thinking we should use? 2 is your answer, your quotient? So you're saying 8 divided by 3 is 2? What are you trying to say next? I think I know what you're trying All right, you have about 30 more seconds. All right, so we're going to bring it back in 3, 2, and 1. So let's look at this problem one more time. Actually read it loud and clear so everyone should have heard it. If you had 8 pieces of candy and you shared them equally with 3 of your friends, how many pieces would each of you get? Leslie?
2. So you have 3 friends and with you is 4 people.
Great
so
job.
you will share 2 one of your friends, 2 candies to the other friend, 2 more candies to their friend, and then you will get 2 as well. So everyone has the same amount.
Everyone gets the same amount. Great job, Leslie. Let's clap it up for Leslie. All right. So as we bring it back, I want to show you how this division that we just did relates to fractions, right? So Leslie, what you just did with your group was you just simplified that fraction. But you have to see what it looks like. So the dividend was 8 and the divisor is 3. Well, I'm sorry, the divisor is 4 because it's my 3 friends plus ourselves, right? So we want to be able to do this by using pictures and fractions and actual division problems. So I have 8 pieces of candy and I have myself and 3 of my friends. So we look at it as 8 divided by 4, right? But when you take another look at it, you can see that what I'm doing is just breaking this up into groups. When we deal with fractions, our numbers are being broken up into parts of a group. A group?
A whole.
A whole. They're similar. They have things in common. 8 divided by 4 equals 2. Great job, Leslie. So then we have to look at it. The numerator of a fraction, the top of the number, is the dividend, right? The line is the division sign. Look up there, Leslie. It's right there in front of you. It's not right here. Now, the denominator is technically the divisor. The same way you would do if you were trying to simplify an improper fraction and turn it into a mixed number or a whole number in this case, because 8 divided by 4 equals what? 2. The fraction and the division problem, they relate. That's all it is. Fraction is a form of division, or fractions are a form of division. Example, we have a mixed number, we have 2 wholes, and then we have 1/2. That 1/2 is what? It's a fraction, right? And that 1/2 has been divided down the middle. So you have to be able to look at that and understand, this is pretty simple. Who can tell me what 2 and 1/2 is equivalent to in the form of division? Let's see if somebody knows. Alexis?
2 and 5/10.
Almost. The numbers are somewhat close. I want to turn this into a fraction that will give me a division problem. That might help. Osmond?
The fraction would be 5 halves.
Yes, 5/2 or 5/2. So I can turn 5/2 into 2 and 1/2, right? Or I can do 5 divided by 2 and I get 2 and 1/2, right? First, if I had $5, I split it in 2, I get Umar $2.50, and I keep $2.50, but I take his $2.50 because I'm not sharing with my money with him no more, right? So, way to look at it. Now, what you're going to do with your table is now, I need someone to read this word problem. Robert, loud and proud.
There are 8 blueberry cupcakes to share among 3 team members. How many cupcakes will each team ever get?
So now we're focusing on how we're distributing these cupcakes. How are we partitioning these cupcakes? Now what I want you to do is think about what we need to do to solve this problem, right? With your tables for the next 2 minutes, you're going to try to do this. Go ahead and begin. Can you do it, Richard? Can you show me another strategy? Okay. Oh, Emma.
I'm sorry.
Let me see. So think about this guy. You said 2 and what? Okay. What do you learn? That's a good way to look at it. What did you guys get?
This is your first team.
Divide.
That's 2 and 8. 2 and 6.
No, you can't put that there. That 2 is a what?
You can do the inverse operation.
Remember, I want you to use that. When you get to that last digit, use that as your what? Remainder. Don't reinvent the wheel. Use that as your remainder. All right, and we're going to bring it back in 3, 2, and 1. All right, so when you do this, you want to think, what do we want to divide among the group in this problem? And how many groups will the dividend be separated into? These are things we have to think about as mathematicians, right? So, Leslie, what do you have going on here?
We divided by 3 divided by 8. And
We did 3 divided by 8?
Yes.
Think about that. How do
8
you
divided by 3.
8 divided by 3.
And we got 2 and 2/3.
Okay, great. So you're moving really ahead of me with the answer. But what I want you to do is think about it. 8 blueberry cupcakes is what we're doing, is what we're partitioning, right? And how many groups are we splitting them into? 3. But this kind of goes back to the very first question with the 3 pieces of candy and, the 8 candies and 3 friends, right? Right. So this one, we don't include ourselves in this, do we? Right. So it should be 8 divided by what?
3.
3. Or if you put it as a fraction, what would it be? 8 over 3. Great job, Jocko. So let's see. We have 3 groups going of the 3 team members. 8 divided by 3 or 8 over 3. And let's see what it looks like when these are my cupcakes. My cupcakes are really nice. I don't have any to share, but these are pretty nice cupcakes. They taste really good. I had one yesterday. I did have a cupcake yesterday. Georgetown cupcake. I don't know if you've been there. Alright, so we have 8 cupcakes here. And how many groups are they being split into? 3. Great job. So we need to figure out how can every person get enough cupcakes. So Leslie said 2 2/3, but I don't have 2/3 cupcakes left over. So we have to think about that. How many cupcakes do I have left over?
2.
And Jocko, this is what I was just talking to your group about, right? Yes. So our denominator is going to be what? What do we think our denominator is going to be? 8?
6,
3.
Johandras? 3. Our denominator is going to be 3, right? So what can we do with these very last 2 cupcakes? Yes, we can eat them. That's the best part. But we have to eat them in a specific way. Favor? I'm going to partition these cupcakes into thirds. So as right, or cut it. As we divide the cupcakes, and this is what I want you to understand, you can only distribute one item at a time. Never try to distribute a million parts of an item at one time. So I'm going to take one cupcake. Watch the video. Keep your eyes on the screen. Not me, Alexis. Look at the screen. Watch how the cupcakes get distributed. Now, do you see my cupcakes were partitioned into thirds, but I shared my cupcake one at a time. I didn't try to share both cupcakes together. I broke one into thirds and shared it. I broke the other into thirds and shared it. This is a strategy for my friends who struggle with simplifying or turning their improper fraction to a mixed number or their mixed number to an improper fraction. All right? Emma. That's my life too. Uma. You could have partitioned it into 6, but that's going to give you a lot more work on your end. So our answer, Leslie did a great job. We have 8 divided by 3, which is equivalent to 2 2/3. Awesome. All right, so what you're going to do now with your table, you're going to actually solve this problem. But before, can I get someone to read it? Loud and proud, Eric.
There are 7 chocolate chip cookies left to be shared among 4 brothers. How many cookies will each brother get?
All right. So as a table, you want to ask yourself which number will be the dividend or the numerator, which number will be the divisor or the denominator, and begin to solve it. You have 2 minutes. Go ahead.
We should add.
Explain how you can compose 8 2. One fraction of a hundred. If you have the PlayStation, you need to explain how the answer to be greater to 8. Okay, yeah, you were wrong. And there's 3 equal size apples, pies.
So it'll be 8 divided by 3.
Which is equal 2 and 3. But this time it said we have to draw up. So you have to draw.
Yeah, I know. You can do both.
I know what it is. Just draw it.
Right?
So the answer will be 2 and 2.
Right? Yeah, and you have to split the remaining.
I think it's already the wrong way.
It's a really equally sized and I want to divide it into
Exactly, so you draw it.
You draw 8 pies. It's so
I disagree with you too, and I think it's supposed to be 8 divided because there's 8 portions, and Emily has 3 equals, 3 equals, so that means you have to divide 8. It's an 8 equal portion. Also, there's 3 pies.
It is 3 pies divided by 2 But it adds a 6 to it.
Okay. Let's see
That's 3 equal size apple pies.
No, she wants to eat that.
She wants to divide
What?
so she wants to divide them into 8 exactly. So it's 3 pies, and then it's divided by
No,
8.
she said she wants 3 left.
It's still a 5. It's a 3. It's a
3 pies.
Oh, so it's 3 divided by 9.
It's still 8.
Oh, wait, no. Everybody's confused. Yeah, 2
Oh, and wait, so what about the 3 pies?
She had it.
Divide 3 pies into 8 pieces. I mean, I mean 3 pies
Divided into 8 pieces.
No, you're not gonna. We didn't get that. All you're doing is turning a fraction into a mixed number.
And then you have to
But you gotta understand that it's a form of division.